All right, we're back. It is COMP123, that's programming 2 in the summer 2016 semester at Centennial, and it's week 8, part 1 of our broadcast. We're talking about a couple things today that are going to help you with your coding. This week, actually, I should probably talk about announcements first, I guess. So announcements, again, there's 2 assignments that I want to talk about. One that's optional and one that's required. But today and this week, all we're talking about is exception handling and file I/O. So we're gonna do a little bit of file handling this week, not too much, because again, we don't do a lot of file handling in the real C# world. We do and we don't, depending on if you're doing a program that's kind of encapsulated, a little program. But if a lot of times we use database, like the majority of the stuff, we're always hooking into some kind of database, right? It's very rare that I'm just gonna do like a flat file on a hard drive somewhere. Again, unless you're making some kind of utility app that doesn't need to hook into a database or something like that. But for the most part, 9 times out of 10, for me, I always hook into some kind of database anyway, right? And why? Because it gives us more capabilities. So stuff we're going to be doing this week is specifically for exception handling, which is how do I handle stuff where there might be a potential error, right? Like if I can't connect to something, or if I'm trying to divide by 0 or something like that. We're going to talk about that today. And then next day, I'll probably hit file I/O on Friday, right? Kind of break those 2 topics up. There's like 2 PowerPoints that I put up on eCentennial for those. So I'm going to be talking about those today. But I want to start off today by talking about assignment 4 and assignment 5. Because many of you did pretty bad on the exam. And we're talking less than 70. That's what I consider pretty bad. So some people might say, Professor, I'll be happy with the 70. Well, I'm not happy with you getting a 70 on the exam, right? So that's why, that's just me, I'm saying, right? Is that? You should all get it. I want you to get all big pluses, but you got to earn it, right? So this is what we did. So I've put together this bonus assignment. It's assignment 4, array and list practice, right? You're going to have a couple weeks to do it. Friday, July 22nd will be when it's due, right? It's optional. So for those people who are watching remotely right now or whatever, do you have to do this one? Let me say that again. It's optional. You don't have to do assignment 4. So if I don't see assignment 4 done by the end of semester, it's okay. You're not going to lose anything by not doing it. It's just a bonus. But it's a bonus of 10 percentage points, right? So it behooves you, whether you need to do it or not, to do the bloody thing, right? Do it. It's not going to hurt you, right? Now, there are some people who are really busy, have busy lives or whatever, and they're like, meh, who cares? It's just bonus. I don't need to do it. It's not required. And that's fine. But then again, so is every other assignment. I mean, at the end of the day, if you don't want to do an assignment, it's up to you, right? It's your money and your time, is what I always kind of say, right? But for this one, what I want you to do is write 2 small programs, okay? So this assignment's going to be a little different than what we've done before. We're going to have 1 solution with 2 projects inside of it, okay? So each project is going to have its own little program. One of the projects is going to be project 1, a dice rolling simulation. We've kind of done this in class, but I want you to practice it. I want you to kind of figure this out. So what it is you're going to use the class random, which is part of C# or whatever. And what you're going to do is you're going to say, let's sum up 2 values that should be calculated. Again, we kind of did this in class. An integer value between 1 and 6, and I want you to tally it inside of an array. Okay, I want you to print the values in the array, this 1-dimensional array only. It's going to tally the numbers, and it's going to print out the array in tabular format, which means in rows and columns on the console. All right, that's it. That's project 1. I mean, you guys know how to do that. So use an array to tally how many times you hit a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, 11, 12, which we've kind of done before. But I want you to do it on your own. Okay, so that's one part. Part 2. This is the more difficult part. Project 2 is airline reservation system. Okay, so how do we do this? We have 1 plane. Imagine we have 1 plane, okay? And we have 10 seats. We have 5 seats that are economy, 5 seats that are first class. Right? It's not really a realistic plane. It's my little small plane. I only have 10 million. I don't have 40 million to buy a real plane, right? And okay, so, and this, by the way, 10 million would be like a used old, clunker that you could fly with 10 seats, all right? Anyway, so let's just say I got 10 seats. And I want to make a menu. I want you to make a menu with your, and again, none of these, both projects don't require any additional classes. You can use just the driver class and methods, okay? because I really want you to focus on arrays and lists, not classes, because I don't want you to be distracted by those things, right? So I'm really going to look at your code here, and it's not really about output and how to make it so much pretty. I mean, make it pretty. It's important for it to look like it's something, but pretty is not really the important part. Can you do what I've asked you to do, right? So here, what I'm asking you to is you have two options. Option one is, hey, I want to choose an economy seat, or option two would be first class would be maybe option one, and option two would be economy. Sorry, it's option three, exit the program. That's in your while loop as an example. We kind of done like a little. Actually, if you look at the exam that you guys did, we kind of did an example of a menu. I've kind of put a system in place where it kind of reads the console for I use console.read key. I'm listening for a particular key, and then I'm adding in I respond to the menu with a 1 or a 2 or whatever. So depending on what the user enters, it's gonna basically assign a seat. Now the seating assignments, the seat chart is going to be a list, right? Okay, the list is going to be of type string, so string type list, right? So each object in the list, as an example, will be a string, so it can hold string values, right? As an example, when you make a list in the beginning, what do you get? If I just go list string is equal to new list, what do I have? Nothing. I have an empty list. I have a container that's nothing inside of it, right? I need to add stuff to it. So I need to build my list up. So there's going to have to be some kind of additional methods. I'm going to leave it to you how to program this. Additional methods to build up the list or initialize the seating chart by adding 5 seats with the value of economy. When I say value, I mean the string value is going to say economy, and 5 seats with a string value of first class. So those kind of 2 things, right? That's how you initialize the list or build the list, whatever you want to call it. As each seat is assigned, I want you to remove the seat from the seating chart list and add the seat to the assigned seats list, because there are 2 lists, right? One list for the seating chart and the other list that's another string list for the assigned seats list, right? I want you to think about this now. Both lists at the beginning are empty, right? They're both empty lists. I want you to take from one, add to the other, right? Same kind of idea that we've been doing. I did it in the deck program. We did a little lab for deck. Actually, we did that lab. We did like the card dealing thing, and probably some of you didn't really do it. They just kind of looked at it and go, oh, here it is. Here's my solution. That one would have helped you do the exam better. That one, right? This one is going to be doing more with adding and removing. All right. So you're going to add and remove. Now, can I remove anywhere? No, I need to remove at. Remove at. Is what I'm probably going to do for this one. So adding and removing stuff from the list. So I'm going to remove from one, add it to the other, right? Your app cannot assign a seat that has already been assigned, because if I remove it from my seating chart, it goes to my assigned seats list. Well, I can't. If I don't have something in my seating chart left, I can't assign a seat, right? So that's how it's going to work. I'm just explaining how this works. So no more seats with the string value of economy exists. Well, then your app should ask you, the person, if you want to kind of place in first class, right, and vice versa. If yes, make the appropriate seating adjustment, right? If no, put a message out that says next flight leaves in 3 hours. That's it. So it's a very simple task. Basically I'm doing shuffling, or moving, I shouldn't say shuffling, moving data from one list to the other. That's all I'm doing. So I'm moving from the seating chart list to the assigned seats list. That's all I'm doing. Okay, it's just an example of, you're going to build a little algorithm to do it. There's no classes, right? Because classes actually make this assignment easier, not harder in this case, right? Just methods. I want you to just use methods to move stuff around, shuffle things around in your program class to make this go. All right. I'm going to give you 5 marks for solution structure. So if you structure your solution properly with 2 projects and all that kind of stuff, I'm going to give you 5 marks for that. And of course, 6 marks for internal documentation. I want you to use proper internal documentation for both little projects that you're going to make. Of course, share things on GitHub, all that stuff as normal. And I've broken out the rubric here as well as online. So you can see the rubric online like we normally do. So this is worth 35 points, but only 10%. And again, this is a bonus assignment. Don't feel that it's required. If you don't want to do it, it's up to you. I highly recommend it. Okay, so that's one. Any questions around this one? Here's another easy one that I kind of put up. This is an easier assignment that we're going to put up for assignment 5. Assignment 5 is only worth 5%. Normally our assignments worth like 10%. But this one is here. It's all around the stuff we're doing this week. But what I want to do is it's a little bit more than just a lab. We're going to do a lab 2 on this. So basically with the lab in this assignment, it's going to almost like have 7% of the weighting of our course is going to be on file I/O and exception handling, right? 2% for the lab, 5% for this little assignment. This one is going to be out. I want you to practice it a couple weeks from now. And again, what if you finish one of these earlier than the, you don't have to, I mean, I'm giving you 2 weeks to do both. Why? Because that means you can choose whichever one you want. You can hand them in anytime over this 2-week period, right? And I'm giving you some space to, to kind of decide which one you want to do first. If you want to do assignment 5 first and then do assignment 4 after as a bonus, you can certainly do that. But I'm giving them both to you at the same time. They're both to the same day because one's a bonus and one's required. 5% for this one. So what I want you to do here is I want you to create a little program again. Again, there's no classes in this one. This is just about file I/O and exception handling, right? I want you to create a grade file, which is a text file, and we'll explain how to do that on Friday. That contains sample student data, and the file should contain the name, ID, ID number, class taken, and grade of every student. You're going to make this little file up, and ensure that the file contains at least a few sets of student data. So it's not going to just be like one line of student data. You're going to make it up, right? Like I'm going to show you how to do it. And then allow the user to load the grade file, right, with the right methods, and display its contents on the console through a use of a menu. Here's another little menu we're going to make, right? So you're going to have display grades or to exit. That's all I want you to do. So either display or exit. You must use a switch statement and a while loop. So I'm giving you some structures I need you to use. I'm forcing you to use a couple of structures on this one. And there's a reason for that. We'll talk about later on. When the display grades options is selected, ask the user for the name of the file to load. So you have to put the name of the file in. Why? If you make an error, file exception handling should kick in and say no such file. It shouldn't shut down your program. If your program shuts down, and I'll try and shut you down. Well, my whole scope for this one is to try and break your code, right? So for you, it's all around using exception handling to stop me from breaking your code, right? It'll just say, you entered the wrong file name, or there's no such file, or whatever, that kind of stuff for this one. When the display grades option is selected, ask the user the name of the file, and your code should include exception handling, like I said. If the file does not exist, the student will be loaded. The student data will be loaded into a string array. If the file does exist, sorry. Each element of the array, oh my God, arrays again. Each element of the array will contain data for one student. If you wanted to use a list here instead of an array, you're totally cool to do that. I have no problem with you doing that kind of thing at all, right? So either one or the other. If you're more comfortable with a list because it's a little easier, you can do that. If you want to just use arrays, that's fine too. When the grade file is loaded, the entry should be displayed in the following format: last name, first name, ID number, class, and grade, like this. Okay, so this is the exact format I want you to use, right? So when it comes up, which means you probably want to align your file to look like this too, right? So all you're doing is reading from the file. I'm not asking you to write to the file. Writing to the file is a whole other thing, and then that requires us to make a much larger assignment. And again, I want you to understand how to access files. We're going to talk about files in I/O for Friday. But more or less, it's just reading the file that I want you to do. Okay? A couple marks for program structure, documentation, and GitHub. And your whole thing is worth 22. So it's not a lot of marks. It's only 5% of your final grade. And again, so 5%, again, this is like required 5%. It's not like it's a bonus. If you don't do it, you get 0, right? If you don't do the bonus, you get 0, but you don't lose anything, right? Bonuses. So both these things, so over the next 2 weeks, you can get 15% of your final grade, 10% of which is bonus that'll add on to anything you lost in the exam, which is something that I wanted to do. It gives you a chance to, I call this my makeup exam or whatever. If it was too hard for you, fix it, okay? Questions around assignment 5. I/O and exception handling. Obviously, you don't know how to do all this yet, or maybe you do, but we haven't had a chance to practice it. We're going to talk about it today and Friday, so don't panic or whatever. And plus, you have 2 weeks after that to fix it, to figure it out, right? Again, assignment 5. Let's get into this this stuff that we're talking about today, and I really want to go over it a little bit with you. So part one is all around exception handling, and I'm going to pull up this first part. It comes from chapter 11 in our book, and that's why I've left that information in there. So if you follow the book, chapter 11 shows exception handling. It's all about exception handling. And we got to talk about what exceptions are. I want to talk about those things. How do I use the exception classes toString method, right? So you kind of need to know about classes to use exception handling, because the exception object itself is an object of a class, right? And it gets generated for you when something bad happens in your code. So something bad happens in your code, an exception gets, we want to call it thrown, okay? Now you should try and handle the exception. If you leave an exception unhandled in your code, your program will break. It'll stop working. It won't continue working with the exception happening, right? So for you, the idea is you need to capture the exceptions and control them, right? Talk to the user and basically say, you've entered incorrect data. And it helps us with data validation, input validation. A lot of the exceptions that happen is because the users entered the wrong data, all right? That's one thing. Other times, exceptions happen when it's not the user's fault, it's something's missing. Like, for example, you're trying to access a file that doesn't exist. Or you're trying to access a database that you're blocked from accessing. That happens too, a lot. Like in here, if I try to access a SQL database on Microsoft Azure, I'll be blocked. Because in our school environment, it blocks those ports, right? And the IP address is associated with them. So, I mean, there's things that can generate exceptions. Also, bugs in your code. Bugs in your code can generate exceptions too. If you forgot something, or the way you coded something was incorrect, you're allowing the user to somehow create, through manipulating your program, he can create an exception, and maybe you didn't catch it. You didn't test your code enough, and it's creating an exception, breaks your code, right? So there's ways of making your code more bulletproof by using exception handling, and so we're going to talk about that this week. This is the first part of week 8. So this is week 8, part 1 is all about exception handling. So again, what is an exception? It's an error, condition, or an unexpected behavior in executing the program, right? So this will definitely come up on a test. The quiz next week, when we're talking about exception handling and all that kind of stuff. Remember, next week's quiz will be on this week's stuff, right? It's always that way. So just be prepared for that kind of stuff, right? So I mean, again, it's all around this stuff. Like, what is an exception? It's an error, right? But it's an error it's unexpected behavior, or whether it's from the user, I want to say it like that, or it could be unexpected behavior that happens as a result of bad coding, right? Just saying, like, you made a mistake, you're using a class in a way that causes the exception to occur. Now, this little reference card here is just about all the different kinds of exceptions. So I'm not going to go over it too much, but if you were to zoom in, let me zoom in a little bit on there. You can see that there's different kinds. There's a system argument exception, where this is thrown one of the arguments provided to a method is not valid. So let's say, for example, I put an argument, throw some kind of parameter into a method. It accepts the parameter. It sees it. It's supposed to be a string, but I'm actually passing it something else, a function or something. I'm passing something weird to but it sees it as a string originally somehow, but later on when it gets passed in there, it's some kind of weird parameter. The data type is wrong. Here's one, arithmetic exception error, right? This happens when you're casting, or something to do with conversion. You're trying to convert something, and it's going to throw an arithmetic exception error. An example of that would be if you're trying to convert an integer into a long or something like that, and it happens not because of you're trying to explicitly cast, but it's something that's happening implicitly, where you're not really meaning to do that, but it happens. Array type mismatch. Let me see what else that you might see a lot. Format exception happens when when a piece of code is expecting a certain format, but you're giving it something else. As an example, I/O exceptions is the one we're going to be dealing with, right? I/O exception, because input output is what I/O stands for, right? And we're going to be talking about that on Friday, so that you can cause I/O error to happen. The other one that's really common is Stack Overflow. Hey, remember that Stack Overflow when it came up? The actual site. It came from this, right? Stack Overflow means And so usually happens that the stack happens when I'm just making a bunch of calls over and over again, and I'm filling up the stack or using up all the memory of the computer, right? That can happen. Stack overflow is what it's called. It's a very dangerous error. Not only can it crash your program, but it can crash your machine, right? And if you're on a mobile device, if you do some kind of stack overflow equivalent, it'll stop your phone from operating, right? Like that kind of stuff. So it's very dangerous. A lot of times it happens because there's some kind of recursion going on where, let's say, for example, a method or a function is calling itself somehow. Like you made something weird where the method keeps calling itself over and over again to infinity, right? Or you're making a calculation and it's an endless loop where it's never going to stop. It's going to keep looping forever and ever, and it keeps adding something over and over, or using more and more memory as it keeps looping, right? Something like that. And depending on how the memory goes, if you really want to, like a Fibonacci number, as an example, could cause a stack overflow error. For example, if I want, I don't know, something like the millionth number in the Fibonacci sequence, and it says, I don't know, something like that, we can try it. I really feel bad, but if you want to try and do some kind of endless loop that way, the Fibonacci, who knows what Fibonacci numbers are, by the way? There might be. It's like this. It goes. It's actually they're found in nature, right? They're found in nature, right? And they go 1 1. Actually goes 0 1 1 2 3 5 8 13 and stuff. And so what you're doing is you're taking the previous number in the sequence and adding it to the current number to get the next number, right? And it keeps going over and over again, that sequence of numbers, until the numbers can go very large very fast, right? So if I keep doing that over and over again, and if I want to try and find some number way down in the sequence, it has to. A lot of times we use recursion for that. You don't have to use recursion, but we do. It's a fast and dirty way of using of figuring out Fibonacci numbers. It can cause something like a stack overflow error. But again, you'd have to make it something really big these days, because we have systems that are much more robust than I had when I was a kid. I could cause a stack overflow error in 2 seconds when I was a kid. My machines are so small, right? And I'm talking about, like, remember when I started programming when I was 10, my computer had 4K of memory, right? Not 8 gigabytes, 4 kilobytes, all right? So it was much smaller. You could crash that thing in 2 seconds, right? For us, it takes a lot more work, and we have a lot more protections in place, and to stop that from happening, but it's still possible. Well, that was a bit of an aside. So again, we have some basic things. The exception class itself, you could definitely cause or call for a generic exception. It doesn't have to be a specific exception. Like when I actually listen for an exception, I can say it's an exception. I don't know what kind of exception it is, but I'm going to get an exception. That's a pretty good thing to do too. You can also do things like nest, this way of catching exceptions one into the other. So you can have, well, any kind of generic exception, I can put it down. And I can also, kind of hunt for any kind of specific exceptions. We'll talk about that in a second. Almost like a user-defined exception that I can make called an app, which I derive from application exceptions. So I can make my own exception classes. And actually, if you actually run any kind of program on Windows, as an example, right, and you're running the program, and it kind of, you're trying to do something and it causes an exception, the program shuts down, right? And if there's an exception number, exception number 1, 2, 3, 4, 5. Microsoft does that a lot, actually, right? Where you have an actual code number, an error number that comes up, right? That error number is not randomly generated from the system. The people who wrote the program created that error number, and they have a documentation that goes, what's that error from? Well, it's from this, right? Because they have a groups of errors or recorded errors that they've kind of put together in their documentation to say that error number 1, 2, 3, 4, 5 means that you don't have connection to the database. And a lot of times it'll say that error 1, 2, 3, 4, 5, no connection to the database, whatever it is. And that's a custom error that you can create. We're going to learn how to do that too. Okay. So stuff that can generate a system exception. This is one that's common. An example of this would be dividing by 0. All right. So dividing by 0 error. And how do we do that? Well, here's how you generate the exception. This is and if we try this code for yourself. So we have 2 integers, so miles driven and gallons of gas, and here it'd be kilometers, right? Kilometers driven and liters of gas here in Canada. This is obviously a U.S. book, and then instead of miles per gallon, it's kilometers per liter, or liters per kilometer, right? And then your console write, enter miles driven, so the person puts in the number, right? Assuming that it's going to be some kind of number, because it could be something else too. They can break it, right? And then miles driven, want to convert this to int32 if it's possible. That could cause an error too. And then here's the dreaded line. MPG, which is miles per gallon, is equal to miles driven divided by gallons of gas. So what if my gallons of gas is 0? Miles driven over 0. I'm not driving anywhere, but I'm dividing by 0, which is a no-no in mathematics, right? It's going to cause this divide by 0 error, right? So let's try that. Let's make a program like that so we can see the results of that. So I've got my Visual Studio kicked up here, and let's make a new project anyway for us for this week. We're going to work with. It's a new console application, and I'm going to call this COMP123 lesson 8. I probably should put in something like summer 2016. Lesson 8. It's part. I don't know if I should do part 1 and part 2. Maybe just even lesson 8, and we'll kind of put. I'll add additional projects in there for us today, if I need to. Maybe get rid of some of this stuff too. Yeah. It's a console application, and I'm definitely going to put it in the proper folder, right? Why am I not using a template here? I don't need a template. I'm just making kind of an application from scratch. And press OK. All right. So I've got my driver class program, right? My driver class program right here, and I got my main, and I want to do some stuff where I take a number and divide it by 0. Let's not get input from the user for a second. I mean, I could do console.readline. So if I go back to what it says here, right here, I'm doing a console.write, and then a console.readline to convert to int32 miles driven, right? But what if I just have 2 numbers? So here's integer, and I say, my first number. Right, my first number is 0, or actually, let's call it what it should be called, right? Numerator, right? The numerator is going to be I don't know, 5, right? Assign it a second, and the denominator. Oof, I can actually spell. Is 0, right? So, and then I want to say my result, right, is equal to, numerator divided by denominator, which is crazy, right? Here's something that's going to happen. First of all, am I going to get an integer result, right? If I divide an integer by an integer, I'm going to get a fraction, right? So theoretically, I mean, I would have to cast. Either way, this would be cast into a fraction, or be turned into, we lose all the details here, right? And I want to print this out. So I want to do a console.writeline, so CW. And then we're going to do a, the result is equal to plus result. I type there. Result. That was weird. That was a Mac thing. And then we're going to run without debugging because we don't need to do a lot of debugging here, and see what happens. Let's generate that error, right? You should get that exception. I want to see the exception error come up. I mean, I want you to see that error come up, right? One day when this thing stops spinning like it's mad. Okay. Control F5. See what happens. Boom. Unhandled exception, and I get this. Lesson 8 has stopped. Right? We never want to see these ever in our code. If we ever write real code, this would be really, really bad if it ever happens, right? Notice that I can't continue, right? This unhandled exception, and it's a system divide by 0 exception, tells you what kind it is right there. It's a system error, right? And it's caused because I'm taking 2 numbers, right? A 5 and a 0, and I'm dividing it by 0. Any kind of division by 0 is going to cause an error like this, right? And all I did this for was just so you can see the error. Let's see what it does. That actually the behavior of the program, it crashes the program. We don't want crashing the program ever. Error. There's different kinds of error. This is a, crashing the program kind of error. All right. There's an error where the error is the information is wrong. You get like the wrong output. That's a different kind of error, right? That kind of error is more of a logic error sometimes. So we think we're supposed to get one kind of output, but we get something else, right? That's a different kind of error. This is, something that we can handle. So how do we do that? How do we handle the error? Well, we use a kind of a format right? First of all, let me go back and talk about this a little bit. It says we can check a variable if we have an if statement before attempting to divide it into another problem. But the problem is when we check to see if this causes the error, it causes the error anyway. If I use an if statement. So it's like I need an if statement that can check to see if the error is going to happen before I even check for it. So we have another structure, the try catch, and that's the structure we're going to use. So we have a try block, and in the try block, it looks very much like some kind of conditional block, right? But we have a try statement, a try keyword, and the catch keyword. So the try keyword is where you put all of the stuff that you want to attempt to run inside that block. Let me show you what I'm talking about. So I want to run this result numerator divided by denominator inside of a block, right? So let me just put my try catch block in place. Now, luckily, we have a shortcut for this. I'm going to make this a little larger so you guys can see. And I'll just kill this thing so you guys can see, have more space to see this stuff. So in my, I can always do try. If I just type try and I press tab, right, I get this try catch. Here's a try catch block. Notice that it gives us a generic exception, right? And it has a throw statement, all right? What I want to do is I want to take this stuff that I want to try to run. I want to cut it. I'm going to put it inside the try part of my try catch block. What I'm saying here is, hey, program, try and run this piece of code. Is it going to work? Yes. Cool. Then if it does work, don't even do my catch block. Ignore it, almost like an else. That's what it is. So if I run it, if I can run this, try and run this. If not, else, run this. Right? So it's almost like conditional statements, but not rather like an if else, more like, can I run this? Yes. I can't run this? No. Okay, spit out some stuff for the user to understand he made a mistake, or to the programmer to make sure that there's a bug, all right? Something like that. Sometimes some code requires try catch functionality. By the way, try catch, the try catch block, exception handling with try catch, is a standard C style, C influenced kind of structure that you see in C#, C++, Java, Swift, and other languages out there. JavaScript, has also this try catch kind of idea as well, a little different, but it has something like that. Okay, so we have an exception. Notice that there's it's an exception class, and this is an exception class. Sometimes what I want to kind of create is an exception object. So let's call it lowercase exception, right? I can't just put the class in there, right? Because the class itself is just the class, right? I want to be able to handle the exception. So here's my exception itself. Let's write down over here a console write line, right? Where I say error, here's my error. And then what I want to do is plus exception, right? And I've noticed what it says here. I put equal. Exception. And if I notice I put dot, dot gives us all the stuff that we can do with that. Right? It's just another object, right? I'm instantiating another object of type exception, right? This is the object. This is the class. Here's my object. My object is exception. Here's the exception class, right? And I have all these methods and properties that I could use. For example, I have a property called message. Here's the exception message. I want to take whatever the exception is, and I want to say error, and print out the exception message. This will not crash my code. This will handle the exception. It will catch the exception. That's why it's called a catch. Before it crashes my code, and it'll spit it out into the console. And then my code, if I want to, can continue executing. For example, if I put this try catch around some kind of looping structure, I can ask a user to keep entering the data until I get good structure. If I don't get a good result, then I keep on asking the user for input over and over again. We'll do that together. Okay, notice that I have a problem down here too, right? My console write line, it says result does not exist. Why? Because it only exists when I define it. First of all, I'm creating a variable that's local to this code block, right? This variable here does not exist in the scope of this static main method. It's only available here in this try block. I mean, I could have created the variable out here as an example, but in order for me to get this, really, as a result, I should probably take this piece of code and put it in here as well. Because of the way I've written it, all right? So again, if I can run the result, I'll put it at put the result here. I'll print it out. Otherwise, I'm going to throw an exception that says, hey, here's my error. Let's try this out. So I'm going to do Control F5, and let's see what I get. Error, attempted to divide by 0. Nice error, right? It's a nice, beautiful error. So it's a very generic type of error that I'm asking for. At the minimum, what I'm going to ask you for from now on, when it comes to user input, is do a try-catch, right? When the user is inputting something from the console, or even if the user is inputting something from a form, because we're going to be talking about web forms, sorry, Windows forms over the next little while, right? So but when we do Windows forms, you're going to get input from the user, right? And it can crash your code just like this. Doesn't matter whether you're doing console applications or whether you're doing Windows forms. The user is notorious for finding ways to create errors in your code and crash your code. I'm the user in this case, by the way. I'm like the devious guy. When you give me a piece of code, a program, I'm going to try and crash your code as much as I can, right? Up until this point, I've assumed that your code is crashless. That you already have validation in place, to stop me from doing it. But after this point, after today, I'm recording this now. We're writing a contract. After week 8, I'm going to crash your code as much as I can. Just letting you know, right? It's going to be a game between me and you. Right? If I can crash your code, you're going to lose marks, right? And I'm going to do it in the best way I know how. All right, let's talk about this a little bit, and let's see how it goes. So how do I fix this? So if I divide this by 10, let's see what the result is going to be if I change this value, a hard-coded value from 0 to 10. So I'm going to kind of do this and then run it again and see what happens with my exception. Well, then my result is 0. Why is my result 0? That's not something that I expected, right? Remember, I just said that I can divide by whatever I want, 5 divided by 10, but I'm going to get a fraction. And a fraction of an integer is still less than 1. That's why I'm getting 0. It's getting truncated. It's getting cut back, right? So I need to fix it. Now, this is a different kind of error. So there's 2 errors that are in my code. One of them was divided by 0. The other one is a logic error. I didn't figure this out, but I'm getting a really weird error here. I'm trying to cast it, right? But I'm trying to get the result of this, and whatever the result is supposed to be is definitely, an int is not the right kind of data type. What's the right kind of data type probably for this kind of thing that I want to get? It's either a double or a decimal or something like that, some kind of floating point number, right? Let's make it a float. For an example, right? If I do float, right? So I'm not casting these 2 things, but the result of these 2 things I'm expecting to be a float, right? Okay, and I'm printing the result out. Let's see if that works. So Control F5, and I get 0 again. What happened? How come I'm getting 0 with the float? I'm just asking. Huh? Well, I didn't cast anything, right? But all I've done is recast this. So this is expecting to be a float. What if I make this a double? Here, I'll change something else. Here, hold on a second. And again, I'm putting this out there because I want you to see that there's 2 types of errors, right? Result's still 0. I'm doing the same thing. 5 divided by 10 is 0.5, right? 5 divided by 10, right? 1/2, 0.5. I can put 1 divided by 2. The same thing would be the same thing, right? So, but I'm not getting it. So I need to cast this. This is the error that I'm getting. It's a logic error, right? That I'm trying to figure out a way of doing this. How do I cast this into a double? Well, I got to convert to, to double, right? By the way, there's a way of doing float. We'll talk about that in a second. All right, so here's convert to double. And so I'm converting this result to double. Is that the right thing I should get? Right? Oh, be careful before I do an assignment. So the stuff on the right side of the assignment operator, the equals operator, I got to cast this to a double and then assign it to a double. Is that going to solve my problem? Control F5. No. How come? The problem is, guys and girls, they're still integers, right? So this is a nice idea, Tom, right? But it's not going to solve my problem. What I really want to do is do one of these. Cast this to a double. How about this? Is this the answer? I love doing this kind of stuff, by the way, because this is the kind of stuff that makes you think. How come my convert to doesn't work, right? And this goes back to programming 1, peoples. You should be able to have these answers. I'm trying to take two integers and convert them to doubles and then get the result. Is that going to make a difference for me? Come on, I want you to tell me in advance. What do you think it's going to be, right? Oh, that's good. 0.5. So 0.5, I got them because if I can't divide it, if I'm trying to make a double, I have to have doubles. If I have integers, when I do the division itself, it causes the error already, my error in logic, right? Now let's make it a float. How do I convert to a float? So I don't want a double precision decimal, right? I want a single precision decimal. So I'll make this float. And I want to convert it. Now notice I'm getting an error now because I'm trying to convert doubles to floats, right? Well, how do I do this? Well, instead of to double, I can go to single, right? To single converts, to a float. I don't know if you guys know that. There we go. And if I do that, and so because single precision is enough for me, and if I press Control F5, then I still get the same result, right? So that's the way I can do that. So I can convert everything, and we're good to go. So I'm building my algorithm. This is how I'm building my thing. Okay, now that I've tested it with basic values, hey man, I could have done a unit test here, right? In fact, I could have built a unit test without a code, put some basic values to test. This is a great one to test on my little main function, right? My little main static main, right? And I could return, it can return something. Right now it returns void, but I could make it so that this is some kind of method that I'm calling that does my calculation, right? And what is it going to take? Two values, numerator and denominator. So let's make this into a method now, this piece, that does the calculations and spits out the result, right? Let's do that. So I'm going to kind of take this, right? And remember that there's, oh yeah, I can't do it this way. I got to go edit, unless you have ReSharper, refactor, and you're going to do extract method. Or you can also press Control R and then M. And what it's going to ask me to is, what's this method called? And of course, I'm going to call this, division. We'll call it division. Divide. divide and show or something like that. I don't know. Divide. It's probably divide and show. Sure. Divide and show. My divide and show method right now, it's got my numerator and denominator. I don't want to have those. I want to call that as parameters. That's what this is going to have. Two things. So here's my numerator, so which is going to be an integer. So two integers, numerator, and then denominator, denominator. There we go. And now I don't want to have these in here anymore, right? Because it's going to be it's a method that I'm building, right? So numerator and denominator, it's going to use these two things, and it's going to return back the result. So it's not going to just print this out, this message. It's going to return the result, right? Maybe divide and show isn't the right exact thing that I want. Maybe just kind of divide, custom divide, sure. I want to, instead of this, I want to return the result. So the result is what I'm going to return. So I'm just going to say something like return and then result. That's what it's going to do, right? Well, because I have a return in here, that means I have to change this from a void to a float, because that's what I'm returning. That's the type that I'm returning, right? Now notice I don't have to put a return in there because it wouldn't return anything, right? But I got a problem with this thing right now. Is this going to satisfy my divide, right? Because there's sections of my code. I'm still getting an error. Why am I getting an error? Well, let's hover over this. It says program divide, not all code paths return a value. Well, that's true, because if I get the right value, I get a result. Well, what happens if I get the wrong value? What happens there? That's bad. That's a bad thing, right? I can actually return something here, right? What about if I return a -1 or something, some weird number, like some number that doesn't make any sense, right? I can return something that it's still a floating point value, right? But it's something that means something to me, right? Some kind of weird, error or whatever. Because remember, I'm listening for returning a float. I want to return a float. So is there some way I can return an error, right? So if I go return, and there's a couple things I can do. I can return 0, right? Can I return null? Is that going to be a floating point? Is that going to fix my floating point problem? No, because null is incorrect. Null cannot convert null to float because it is non-nullable value. Null isn't the way. Nice idea, though. I like your thinking, right? What about if I, is there some kind of meta class? Float, return float? Can't do that, right? So what can I return? How about just a number, like a literal, like 0f? Can I do that? I probably can do that. So it's 0. So if the return, I can check to see if the result is 0. How can I get a 0? Remember, if I'm dividing by 0, right, and I'm checking for dividing by 0, this is actually any error. The only way I can get 0 is if it's 0 over the denominator, right? So if I put 0 over the denominator, I'm going to get 0. It's going to return 0. And if I put something over 0, I want to return 0, right? So 0 might be a good way to return it. It may not make exact sense, right? But it's still returning 0, and it's not going to hurt anything if I get a value back. Okay. Now it's going to kick out this error message as well. It's going to kick out this error message, right? Here's something that I can also do. Notice that I'm declaring my float as result, right? And I'm returning a floating point value. That's what I'm returning. There's other things I can return here instead of a floating point value. Another thing that would really serve me well is a string. Why would I want to return a string? Well, so divide and return a string is what the result is going to be, right? So instead of returning a value, you can return a string, and then I can assume that the other end is going to convert my string into a float if it's valid, and if it's not, then it's just going to keep the string, whatever it is, right? So there's some tricks. Other ways of doing this. Instead of returning a float, I could have some kind of other object. I can make my own custom object, right? And I can return different values of my object. One of them could be the thing that I'm looking for. Another one could be an error, like actually an error property of my object. And if the error property of my object exists, then I can ignore my actual value, right? So different ways of doing the same thing. There's never just one way of fixing this problem. I'm just creating a simple solution here for us to play with. Okay, so my divide has a problem now. I need to add a couple of values in here, and this is where I'm going to get the user to enter in those two values, numerator and denominator, right? So I can kind of create them here. I can say, well, I'll say int. So let's say, we'll call this number 1, our first number, right? My first number, and int is my second number. And then what we'll do is we'll say something like this: console write line, enter, your numerator, whatever. And it's really my number, right? And what I'm going to do here is my console write line is going to ask me to do that. Well, let's make it a console write, so it'll do it in the same line. Then I'll do a console read line. I'll say then my first number, right, is equal to, and again we'll convert to single, whatever I get from my console read line. It doesn't do it. Console read line. Okay. I'm going to get something from my console, read it in, and convert it to a float, which we'll call it actually, it's not convert to single, it's convert to int32. I'll be okay. int32. And so I'll convert it to an integer. So 2 integers. So whatever integer, I get 2 integers. So enter an integer is what I want to say here, integer. Right? And then, because I got to be specific with my user. And then I want to enter a second integer. So enter another integer. Again, I'll do the same thing. I'll copy these 2 lines, put them over here, right? Put them over here, and this will be the second number. Again, we're building up our little code here, right? It's first number and second number. You guys have seen this stuff before. And this is enter another integer, another integer. So first one is an integer, another integer. All right? And then what I want to do is take the first number and the second number and put them in here. Send them to my method. So first number and then second number. Right? And then it's going to divide first number and second number. Divide. Notice it has an action. I'm doing something with my numbers, first number and second number. Dividing them 2. We've seen this kind of stuff before in programming 1. This is a nice review, right? And it's going to print out it's going to return the result. So divide actually is going to return a float. So what I want to do is the result is whatever it is. So this is going to return something. So what I can do is something like this. Console write line. I'll write this in 2 lines here for you. Console write line. And I'll do something like this. The result plus, and then I'll take this, because this returns something, right? It returns a floating point number, and I'll pop it right into my console write line, like this. Because this statement right here is returning a floating point number. That means whatever my result is going to be is going to add whatever the return value is of this into my string result, right? So I can do that in 1 line. Let's just clean this code up a little bit, right? And so we can see that. And now we're still using a try-catch block. We don't use it here. We have a try-catch block down here in the divide method. All right, let's run this thing. So I'll control F5, see what happens. Enter an integer. So we're entering same thing, 5. Enter another integer, 0. Result is what happened? How come I got an infinity? I was expecting to get something else. Guys, what's going on? How come I got this? Right? I didn't even get an error. By the way, I knew this was going to happen, right? But I wanted to show you this because what you think is going to happen and what actually happens are 2 different things. I get infinity, right? Actually, I didn't even know this would even. I thought it was going to crash, but this is good, right? Oh, but I don't understand, says Tom, because I'm trying to, be my, my third party here, because I should have got an exception, right? It should have generated an exception when it went through this thing. It should at least been able to return 0, right? And somehow I didn't even get here. How come? Well, let's see where it did get to. How do we see where the program is executing? We need to put some kind of stopping point or debug point, and we can put that in the point where it comes to my try-catch block. I'm going to start putting it in here. So inside, as soon as it gets to here, this is my stopping point, right? My debug point, right? I'm putting it in here. So if my code executes and it comes to this point, it's going to stop and allow me to do my execution step by step. Let's try this out. So again, I'm going to kind of control F5, run without debugging. And if I press F5, and then 0, and then I get the result, no debugging. But if I run with debugging, I can actually do step by step. So here's my 5, and then 0, and now it's going to take me to this point. And let's take a look at some of these values, right? I've got a couple things here. I've got my autos and locals. I want to go to my locals window. By the way, they should be appear here. If it doesn't appear here, you can always go to View. I think it's Other Windows. If you don't get those, think Values, Autos, and Locals. It might be under Debug. Probably under Debug. Debug. Let's see, Windows. Here you are, Autos and Locals. You can actually, if you don't get those values, you can actually bring them up here. And notice that the numerator here is 5 and the denominator coming in is 0. This is correct. My result right now is 0. It's a floating point number, but there is no result because my result is being defined inside my try block. All right, let's continue to step through. So I'm going to step into, it says float result. Let me just make this a little bigger for you guys to see because I'm kind of running this thing here. Forget my diagnostic tools for a second. I want to see what happens here. So it's come to line 29 now, and it says float result is equal to convert to single numerator, and then divide by convert to single denominator. It's kind of doing that thing now. Okay, let's see what happens now. So, well, all right. My result is now infinity. I didn't get that before. My result was giving me an error before, not infinity, right? See? My result is infinity. It's not an error. Somehow I'm getting an infinity result. That can't be right. That's what happened, right? I'm not generating an error anymore. I'm just getting back infinity, right? Let's continue. So if I step through it again, it goes back here. It skips over the catch block, right? And then it goes to here. And then when I click next again, all right, if I keep on going to the next operation, it actually prints out infinity over here, right? That's what it does. And then it'll take me back, to my console. So that's what I got back. It actually did the calculation here. But when it was running over here, right, or before I had it in this, this state, when I had integers and numerator and denominator here, I had my own values, but it was running here in my main program, no problem. It was running. Well, there's a thing for that. We'll talk about that in a second, because I want to run my try catch, and somehow it's giving me a weird error, and I don't know why it's running like that. We'll talk about that. But that's not the right result. Infinity is like, yeah, it is infinity. I don't even know how I got that, right? But it shouldn't have. Should have errored out. All right. I want you just to see, because again, expected results versus would my test, if I built the test for this class, it would have failed right now. Would have failed, because I would have expected a result of some kind of error, and I'm actually getting infinity, which is totally wrong. My expected results are red right now. Okay? All right, let's take a look at this. So then there's a couple things going on here. One of them is thinking. Is my thinking correct, right? Thinking for a programmer can cause errors more than anything else. It's not other stuff. It's not division by zero stuff. It's this. So we have try block. We've talked about the try block. We'll get back to that error in a second. We've got our catch block, right, which catches the error and then does something. We can execute some other stuff in there, right? And then we also have something else we haven't mentioned called the finally, right? So we can go try, catch, finally. And this is kind of the way it works. We've seen this already. Try some statements to run. You want to try it. And then if there's a problem, do something about it, right? That's really what it does, right? And then down here, below the try catch, they execute regardless of whether there's an exception or not, down here. Regardless of whether there's an exception or not, it's going to execute. That's what's going to happen. Okay. Let me ask you this question. Is it because we took two integers before, right? I want to figure the error out with you. Remember, before my original was take two integers, divide them, and then we're going to get a divide by zero error. When I turn them into floats, we didn't get that error anymore, right? And here's the way to capture that error. What if we turned it back into integers and we kind of did integer division to create my thing? Would we get an error then? Let's check this out, because I want to recreate this error, right? We got infinity. That's not what I was expecting, right? Well, let's unconvert these. Let's just take these out for now. I'm gonna actually, you know what I'll do is I'll comment out this code, and I'll put in a variant of this code underneath it, like this, where I kind of have the floating point number be an integer. Right, there we go. My result is an integer. Let's make my float, instead of float, it's going to be an int. We're going to change that as well. And instead of converting to single, we're just going to make numerator as an example and denominators. I'm changing back my code to see what I get, right? Because is this the issue, right? So because I want to check out, see what this is. Now this can't be 0f anymore. It's got to be 0, right? And now I'm still entering two integers, but I'm not converting them anymore, right? Let's see what happens now. Just as an aside, see if it crashes. Integer number 1, 5. Integer number 2, 0. There's my lovely error that I wanted. But when I made them floats, it gave me the infinity sign, right? So it wasn't an error in what I was trying to do. It was an error in thinking. I didn't have any kind of error when I was dividing with two integers. How about, here's something that I can also generate another error. We've just done number divisions. How about other kind of inputs we can cause an error to happen? Here's another kind of error we can have with integers. And then we have an unhandled exception, right? This is another exception we haven't handled, right? Look, I'm listening for integers, and I'm trying to do the conversion, right? But I'm actually trying to convert something that is not convertible, right? Let's fix this problem. So first of all, let's put everything back the way it was, because this isn't right. So we know what the problem was. The problem was once I converted to float, right, and I made it to float, everything, it created that infinity, right? Because it's true, it is infinity, and our computers nowadays, I guess, are smart enough to figure that out. But what if it's not an integer anymore? It's something else. I'm converting to integer, but I'm actually entering something else. So let's make a try catch block that kind of goes around this stuff, right? All right, so let's try this out. So two try catch blocks. So here's try catch. We can run it like this by ourselves, so we don't have to wait for the try to run itself, to write itself, right? Here's my results, right? So I'm going to try and do this, and I'll have a result. Else, here's my catch, right? As the worst case scenario, I want to use the exception class to create an exception, right? This is my exception object, right? And inside my exception, down in here, I want to put out something like, you know, you must enter a valid integer, something like that, because that's probably the answer, right? So console write line. Remember, because I can still enter whatever I want, unless I had another piece of code that did, you know, input from the keyboard, right? From the user. Console write line. Please enter, you know, valid values or a valid integer. Enter an integer. Integers for your. What this integers? Now notice I'm not using the message. So do I need to actually use this class? And could I just take this whole thing out? Just curious. If I wanted to, could I write my catch like this? And the answer is yes, you could. So let's say, for example, I don't care what exception it is. I just want to pump out an error. If there's any kind of errors, it's going to say please enter integers. Yeah, it's kind of, you know, thing. Can I do that? So I could do it like this, and I can do it like this. There's a couple other ones we're going to talk about if I want to specifically handle errors for different kinds of results. Because what if it's not an integer, right? What if it's something else? Let's try this out. So try catch, integer, please enter integers, right? Or you didn't enter a valid integer, you know, invalid input. We could also put that insert. That's kind of really generic, invalid input. We can put an error in there, error, invalid input. Won't crash our code though, right? Which is really important, right? So console write line, error, invalid input, and then again I can run it. And if I run this again, error, invalid input, it'll come out, right? And what about if I handle something else? Like if I write a number, here's another error, another possibility of an error. Remember, there's different ways of breaking your code, right? I'm just saying, right? So here's another number. So write this in and enter. That didn't give me the desired result. Let's try that again. So Control F5, right? Enter. Invalid input. That could be an invalid input as well, right? Enter could be an invalid because I'm not entering anything, right? That's another option. Here's another one. What if I enter not an integer, like 1.5? That's not an integer, right? So 1.5 is still a number, but it's not an integer, right? I didn't say enter a number. I said enter an integer, right? And what if I have two different kinds of integers? I have or two different kinds of numbers. I have an integer. Some user might enter an integer in one, and then a number, a floating point number, or something else in the other, right? That could also cause a problem, right? Because I need to know which one to convert. How do I convert one to the other, right? So conversion errors and all that kind of stuff. So lots and lots of errors. Users notoriously can figure out ways of breaking your code, and you don't know, you can't predict what they're going to do. But you could put this catch-all, what basically says, hey, whatever I get, it's some kind of invalid input. I don't know what it is. Invalid input. At least my program won't break. It'll politely close down. That's what this is doing. Right? It'll nicely shut down, nicely, and it won't break my code. You won't see that ugly message that says your code has crashed your program. We don't want any kind of thing, any kind of crashes ever. And this is a good way, at the very minimum, to do it. Let's take a short break here. I've kind of talked for about an hour now, and then when we come back, we'll handle more exceptions.